All right, hello. This is Mr. Kimpton.
And Mr. Gilbert here.
We're going to talk to you a little bit about what early Earth was like and how it formed.
So get ready to go. Chapter 4.5, the early Earth. And the early Earth, well, we got to talk about the Earth is approximately 4.6 billion years old. That's a very long time ago.
Long time.
God, that's older than you are, Kimpton.
I know.
Jeez.
The majority of Earth's history was actually the formation of the planet. So it took a long time for this giant ball to form. Layers of the Earth, the atmosphere, its oceans.
And here's a summary of what happened during the first 3.6 billion years of the life of our planet.
All right, so first, scientists believe that the Earth began as a big ball of dust, rock, and ice in space.
And gravity was pulling these masses together at about the same time the sun was forming. Gravity is strong stuff.
Yep, it likes to pull everything into the center. Gravity increased as more and more material formed into that ball.
And as you're getting more and more material squishing together, the temperature starts going up and going up and going up, and you're getting a really hot spherical shaped magma, metal, glom, thingamabob that's eventually going to be our planet.
And so, like you learned in sixth grade, things that are more dense and in liquid form will sink through other things that are less dense. So the majority of our most dense material is in the center of the Earth, and that's why that's how it got down there. It was a big ball of liquid magma.
So that crazy thing called the iron catastrophe, when iron finally solidified and sank in our Earth, is why we have this really solid metal inner core.
Yep.
Heavy duty.
Literally. So all the molten material that was lighter and less dense is what started to form our crust. So in that last little picture you can see on the slide, here it's like a skin of rock that started to form. And that's what gives us the giant plates of crust that you'll learn about in a few weeks to come that gradually move around on the surface of the other layers below.
So heavy stuff sank, light stuff floated.
Here are some things that would be good to be able to put in order. These are in order. The first atmosphere, once we were able to get an atmosphere, was actually hydrogen and helium. But our big, powerful star, it sends out solar wind. It blew it away. That's why we don't have that type of atmosphere anymore.
So then the second atmosphere was forming as things were cooling on planet Earth, and it was mainly carbon dioxide, nitrogen, and water. Ooh, water's good stuff.
Then, with the cooling of the crust, we have volcanoes forming and spewing out gases, and one of those gases that they spew out is water vapor. And we also have comets that are being pulled into Earth, and those comets have a large amount of ice, actual solid water.
So as the planet continued to cool, the water vapor, a gas, cooled down enough that it could actually start raining on planet Earth. And think about it, when you get rain, you fill up the depressions.
And then that rainwater accumulates, and that's a lot of rainwater, and it forms the oceans.
Yeah, but this occurred over millions of years, so that's a lot of time.
Billions.
Billions of years.
Billions of years of rain.
Finally, the outermost part of the solid planet, the plates, the crust, the lithosphere, and the parts above water, the continents, began to form and kind of started moving around.
And then it took a long time for Earth to actually have life form on it, and the earliest simple life came around 3.5 billion years ago, and that's very simple life. We're talking about single-celled organisms.
And we'll be going into more detail about these organisms and other life and how the planet's crust or lithosphere began moving in future days. So be prepared. Get ready for questions.
Ta-ta for now.
Uh-huh.